Concatenating data can be thought of as stitching together data that was once a single data set. But this is not the only way data can be combined. Here are two data sets, one of the US states and their population, and the other contains US states and their two-letter abbreviation. If we wanted a single data set that contains states, population, and two-letter abbreviation, concatenating the data sets together will not work. In this particular example, we cannot concatenate the data frames because the ordering of the states are not the same. The last way we can combine data is by merging. If you've heard of or familiar with SQL, then Pandas has the same capabilities to join tables. Merging data allows the analyst to combine disparate data sets based on a common set of columns. We can merge these two data sets by matching observations on the state name and end with a new data set where we have the full state name, the abbreviated state name, and the population all in a single data set. Here, the keys will be the state on the left data frame and name on the right data frame. When we merge on these keys, only the state names that are the same will be matched together to create a new data frame. In order to perform a join, we use the Pandas merge function. You pass merge two data frames, the left and the right data frame. If the columns you want to use as keys to merge on are spelled the same, you can use the on parameter and specify the key. However, in our particular example, the column names are different. You need to specify the left on and right on parameters for the individual keys. You only need to specify the on parameter or the left on and right on parameters. Our merged result has the full state name, the abbreviated state name, and population in a single data set. There are three different types of merges that can occur: a one-to-one merge, a many-to-one or one-to-many merge, and a many-to-many merge. The US state populations example earlier showed a one-to-one merge. The left data frame and right data frame all have a one-to-one corresponding key. That is, there are no duplicate values in each column that we are merging. If there are duplicate values in one of the keys, then the values from the other key will be repeated to fill in the duplicates. There are multiple cities in each state. When we combine the city dataset with the state dataset, the values for the state code will be duplicated for each value in the city. This is the one-to-many or many-to-one merge. These are the same types of merge. It just depends on which order you specify the data frame with duplicate keys. The various types of merges you can do, one-to-one, many-to-one, or many-to-many, all use the same function. The only difference is the data frames you are merging together. Now it's your turn to merge together multiple data frames to create a single data frame, and you'll see what happens in a many-to-many merge when both data frames have keys with duplicates in them. Now let's put everything together. We're going to use all the data cleaning techniques we've learned in this course on Gapminder data. The Gapminder Foundation is a nonprofit that promotes sustainable global development. At the end of the chapter, you will have a clean and tidy data set that will be saved to a file. This will allow you to load your clean data directly for your analysis without worrying about cleaning your data again. The data set we will be working with is the life expectancy by country and year. Our data will come in multiple parts. We will load one of the parts and do some preliminary data quality diagnosis. We will then combine all of our data into a single data set before performing more data cleaning steps. Remember, we first need to load the Pandas library before using any function. To read in data, we use the readCSV function. We can use the head and info methods to look at our data and some basic information about our data. Things to look for here are missing values and column types. The columns attribute will give us just the column names. We can get descriptive statistics by using describe and value counts as a way to screen for outliers and potential bad data. Many of the plots we can create stem from the plot method. For example, we can create histograms by passing the plot method the hist argument. We can use functions and apply them over our data to check for data quality issues. Remember, a Python function that you want to apply to your data will look like a regular Python function. However, the data that will be passed into the function will be a row or column of data instead of a single value. We can use the apply method to use the function row or column-wise. By default, apply will work column-wise with the axis parameter set to 0. If we set the axis to 1, then the function will work row-wise. We use assert statements to check that our expected value is the same as the values in our data. If no error is returned, then that means the value passed into the assert statement was true. To combine data, we can either merge or concatenate them. In practice, you can either clean individual parts of data before combining, or you can combine all your data first before cleaning.